Hello everyone. This session will be about regular expressions. If you've never seen a regular expression before, or even if you've got a little bit of experience, you might find this session to be interesting. Okay, so why do we use regular expressions? We might use regular expressions to do text processing, to search for certain patterns, and so on. So for this session, I'll keep it quite simple, and we'll use just the set editor, and let me just start with something simple. Hello world. Okay, so if we send this hello world input into set, we can do various transformations. So the most common command that we would use with set is substitute, and we could say substitute hello to hello, so from and to. Okay, that was easy. That didn't involve using any regular expressions. It was just changing a word to another word. And again, this is the basic session. If you think, oh wow, this is way too easy for me, please swap to the advanced session, which will be in an upcoming blog post. Okay, great. So now that we're ready to get started with regular expressions, let's start with something simple. What we've done here is we've said substitute the beginning of the line, and the beginning of the line is indicated by this little character here with uppercase hey, with an uppercase hey. So, and you can see indeed it has inserted that. We can similarly do the back of the line, which is this one. So could we do something like this? No, because here we're saying substitute the beginning of the line and nothing in between, end of the line, with H. Now, of course there's no such thing because here we got text, but how about if we were to say no text at all? Then this might qualify, and indeed it qualified, and it has swapped beginning of the line to the end of the line with H. So let's go back here. And let's do something a little bit interesting. So now we've got this double HH here, so how can we cater for that? Well, let's try this. Okay, great, so we've changed in a very similar fashion to what we did here, the H into an uppercase H, and we've done that by saying at the beginning of the line and then a little dot. Now this dot means any character whatsoever. Let's have a look what this would do if we just start like this. It does the same because it says any character, and in this case the first character it finds, and note that we're working with set here. Substitute that with an uppercase hey. Okay, so how about if we did two dots? Well, now it gets interesting because it has taken indeed the first two characters, any character, and it's replaced that with a H. How about if we were looking for an actual dot and not any character? Notice now we're not using a regular expression anymore. We're looking for a fixed dot. And of course that doesn't work. How about if we were to actually use a dot? That works. Or if we were to put the dot here just to make things a bit clearer. Yeah, indeed, that dot was replaced. Now, set has this great option where you can say, let's just go back to this regular expression use. So here we've again taken any character, which in this case happens to be H, and we've replaced it with H. We can even say we'll have a H and then any character and replace it with H. So in this case it has matched H, then any character, which is E, and it's replaced it with H, and indeed the output matches. Now set has this great feature where we can say global, and indeed now it has matched any character across the line globally, so it keeps repeating it if you will, and it has replaced any character with H. Okay, great. So what if we were to use this? Do you have an idea what it would do? If you guess it was this, you got it right. So here we are, even though we've got this global here, we are working from the beginning of the line, and then we have any character. So in this case, it will match this pattern and replace it with H, and it will keep doing that. But there's no more beginning at the line as soon as we are no longer at the beginning of the line. So you can see how that worked there, and how this replacement was done only once and not across the board. Okay, so let's do some more interesting things. How about if we say any letter A to Z, and we surround this with square brackets, any letter A to Z, replace it with an underscore. Now look, interestingly, it's replaced the E and not the H. This is because A to Z is lowercase here. Now there's two ways of changing this. We could say work case insensitive, which is a set option, or we could actually fix this in the regex and say match A to Z as well, and of course that would be the same as A to Z, right? And just like before, we can do global, but again, because we're using uppercase here, it's only swapped the first letter. So if we were to do this, what would it give? I hope you can see it by now. You're right, all underscores. Note the very interesting occurrence here of this space, which was not swapped because it's not a letter A to Z. So we can add a space, and sure enough, every letter is replaced. How about if we just add a space? Sure, it's matched. How about if we didn't close it? Sure, it's still matched. So why would we want to enclose things into brackets even if they're one letter? Well, there's a few reasons. For example, if we were not to use the G, there's a way of doing this a little bit differently. So here, what happens with the global is set will keep looking for matching patterns. Now we're going to do this slightly different. We're going to say we're looking for A to Z, and if you find one or more, and one or more is indicated by using backslash and then plus after this particular regular expression. Now, depending on what editor you're using, these formats might differ a little bit. You might actually find that you have to leave out the backslash, and the syntax might be like this. It depends on what standard you're working within. But for set, we use this particular option. Now let's have a look at what happened here. So it looked for a lowercase a to z, and it's found that here. And then it kept matching. Remember, this means one or more, and it's found 1, 2, 3, 4, and then it comes to this, well, previously underscore, but this space, and it will swap all of that with a single underscore. Okay, great. So that has worked. We've looked for H, we found an E, LLO, and it swapped that to underscore. Now, what would happen if we run this? Who can see it? So here it's taken this particular pattern, which is the result of looking for A to Z one or more times, and notice that the one or more times means up to the moment you find something else. And up to the moment you find something else in this case means a space, and replace that with underscore. Now we're doing that again, so now we're using the power of set to look for a second occurrence. And so now, past the space, as soon as it goes past the space, it goes, hey, I got here a W, which can match my pattern, and actually, one or more, so the whole word here matches, and indeed we get H underscore underscore. Okay, so let's remove this again. Let's look at some further syntax. We can use asterisk here, which means 0 or more. So 1 or more or 0 or more has a slightly different working. So let's have a look. It looks for A to Z, 0 or more. And as soon as it's even just at the very start, it says, okay, I've already got a match because, it needs 0 or more. So where would 0 or more be interesting? Well, let's say you're not exactly sure whether world starts with a W or not. Let me write it like this just to make it clear. Okay, so whether world will start with a W or not, it will both work. So you can see where it becomes interesting to use 0 or more. Okay, what other syntaxes would we have? We can have 1 to 9 or 0 to 9. And in this case there is no matching text, so that will work just fine. How about if I insert 1 here? Now it's changed the 0 to 9 to 1. And I hope you can see what this output would give. Notice that there is no global, no G, and notice that there is no particular repeat for the regular expression. So how many characters will it swap? 1 or more? I hope you can see it's only 1. Indeed, it has just changed the first one. How about if we were to do this? Now it's taken all of the letters, because remember, 1 or more. How about if we did 0 or more? This is interesting, isn't it? So here we've said 0 or more and replace it with an underscore. That's because I got a little error in my syntax here. There we go. So 0 or more, and you can see how you really have to remember where to use a backslash and where not. And again, in different editors this might be slightly different. So 0 or more, and indeed it's replaced it to an underscore again. Okay, so let's do something else. How about if we add hello, then we're not sure if there's going to be a 1 or a space or perhaps a tab, and the tabs are indicated like this. And we would say, well, at least you need to have one of these, right? Or you could say, well, if you have any of these or none of these, still match the pattern. So we're going to say 1 or more, and then we might have a W, and then the rest of the text. Okay, great. So it looked for hello, it's found hello, then it said 1 or more of either a 1, a space, or a tab, and indeed it found a 1. So what if we were to remove the 1? It shouldn't work. Okay, and no substitution has happened because the 1 was removed. And then we might have a W or we might not have a W. So if we were to go back 2 up and we remove the W, it should still work. Little mistake in my syntax there. And that worked fine. So just to clarify, you need to indicate whether it's 0 or more. If you just have this W between brackets like this, it actually looks for a W, but we could say look for a W, an A, or a B. And if we then insert B, it still works. If we insert A, it still works. Or we could say 0 or more, and then even if there was no occurrence, it would still work. If we had 1 or more, it would not work because there is no W, A, or B. I hope you can see how that works. Okay. How about this? I hope you can see by now what this would do. It would match any character 0 or more times. So 0 or more times any character means the whole word or the whole text, and it would become an underscore. So let's take this a bit further and say you will have the beginning of the line and an H. You definitely have to have that situation. Then any text, then LD from world at the end, and the end of the line. If you see this, then you should match. And indeed it matches. How about if we say past the end of the line you should see a T, and of course that doesn't make any sense, so it doesn't work. Or how about we need to have a space somewhere in the middle there, and then any more text, and great, it works. Now this becomes very powerful, and I'll show you a bit of an advanced tip. Let's say we're matching the word hello, and sure enough that matches. But notice how I've used backslash, bracket, backslash, and here again, and here we will say 1. Now this looks a bit interesting. So you got these curly brackets here, you got them here, and in between the word hello. Now what it's doing is it's saying match this particular section, and we saw indeed here it matched the word hello and it replaced it with underscore. But here we're saying replace this word by \1. Now \1 is simply an indication for the first section you've placed between these curly brackets. So if I were to do 1, then I hope you can see what's happening. It's taken this section and it's replaced it with whatever it found here, and then again, and then and again. So you know, if I were to use 2, which would be the second match, there wouldn't be anything there and it would give an error. So let me show you how that could work. We can have a space, world, and indeed that works. Or we could say like this, and it would be world hello, because we've matched this as the first match, we've matched this as the second match, then we're displaying the second match and then the first match, and it would be turned around, and we can keep going like this all day and use that particular pattern which we've matched. Now this becomes very powerful because you could do something like match everything, and display this. Of course that's not very interesting, but how about if we said you can have any space or tab and then world. So I hope you can see what this is going to do. It's matched everything in the string. Here it's matched everything up to a space or a tab, so in other words this, and this. Then you have a tab or a space, so the tab or the space, then the word world, and swap all of that by the first match you've made, which was surrounded by curly brackets. Okay, so let's have a look at where else we could use this. Okay. So in this example, it's taken the word test and grab for that, and so if we insert a space here, it will only grab the first section because it's only seeing this once. So let's see if we can use a regex here. So, and I'm adding this to make sure that my syntax matches correctly. Okay, so here we've used the regular expression again, any character 0 or more times, and we can say 1 character because we know that it's just a space. We could say a tab or a space, would still work, 1 or more times, and here you can see how the syntax difference already comes into place when we use egrep or grep minus e. then the syntax is different. We don't use the backslash. That was what I was saying before. Or we could use 0 to 9, A to Z, which is not going to match because it's a space. Or we could have a space. We could even use this, and indeed it matches. And so you can even use Q to do, if statements. So we can say something like if grep, then go found, go not found, and indeed it finds it. If we remove that, which would mean that we don't get a match, then indeed it's not found. And so you can see how it becomes very powerful, because you can use this questioning together with if and see if you have a pattern match. So let's see if it would match any pattern, and sure enough it's found. How about if we say you can have A to Z, A to Z 0 to 9, you can have a pipe, and sure enough it finds it. But what if we say you can only have A to C, and the reason why that works is because it is matching only a single character. So we can say okay, so here it will be looking for the character A to C in the first position, which is not there, and then for any other character, so we might just as well say any other character, and it's not found because the first letter is not a T. So just for making things clear, let's do it like this. This is the one we need, so that we can see what is being matched. And we can see that the pipe in the middle here is the one that's being matched. And indeed we're working with grep here. So this particular character seems to have no, it's not precedence. The reason is that all of these letters fall out of the A to C range, and this particular character is the only one that matches. So if we were to do this, it would be exactly the same, and you can see why it's being matched. Well, of course, if we do it like this, we need to backslash it. You can see how you need to get your escaping right. Sometimes you end up with really funny things like 4 or 5 backslashes and so on. Okay, so let's make a little test file. So if you notice what I did, so here it's got 3 spaces, 2 spaces, 1 spaces and a tab. And I'm just going to write this out, and if we do test get test file, we can see and what we can do is we can substitute the beginning of the line with a little insert, and we can substitute, and here I'm just using 2 different commands after each other. They're separated by the semicolon. Substitute the end of the line and terminate it. So you can see 3 spaces, 2 spaces, 1 space, and a tab. And you can see how, set with regexes can become quite powerful. So beginning of the line, we could do something like this. End of the line, we could do something like that. And it becomes quite clear where there's spaces or something happening. So how about if we didn't swap it to anything, but we say grab anything that's got a tab in it. Oh, right. Seems to be some interesting shortcoming with set with grab, so I'm gonna do it another way. That's better. So here we got the tab, it's being replaced. And how about if we were to replace, and by the way, instead of this particular character, you can use any character, right? So I can say looks a bit funky, but all we've done is just substitute the separator to another character. I hope you can see how that works. So here, let's substitute the beginning of the line to the end of the line with blank line. And we can indeed see that our last line, which didn't have anything on it, is being swapped to blank line. We can say any char, and indeed it swaps all of them. And why did it swap the last line even if it didn't have any char? Remember that this means let's write it like this, and now we have a dot like this. So here we were looking for an actual dot, and here we were looking for any character, and you can see how the last line wasn't changed because this means one or more. Zero to 9, 1 to 9, and so on. So just to recap, we can have the start of the line, the end of the line, a selection of characters, right? So we could have A, C, D, or A to Z, A to Z. We could have 0 or more. We could have 1 or more, and we've seen pattern matching within set. And let's have a fun one just to end with. I hope you can read this by now. So what we've done is we've just changed the delimiter in set, so I could have just as well used slashes. Then we're looking for any character, and we're going to swap that with A, and we're going to do this globally. Oops, and of course we need to point it to our test file. And here we've swapped any character, so on the last line there was no character. Here there were 3 spaces, 2 spaces, 1 space. Because remember, we're repeating this, and we swapped it to A. Or we could have just swapped it with itself, and the output is still there, and so on. So that was a simple introduction to regular expressions. I hope you enjoyed it. God bless. Bye.